Okay, so we are here this morning, fresh and crisp and bright, and we have with us the first speaker of the day. He is an engineer who has spent more than 40 years in software and software testing. And as a systems software consultant and trainer, he supports software product integrity, verification and validation with a specialization in embedded IoT and mobile software systems. And he authored the book, Software Test Attacks to Break Mobile and Embedded Devices, and has published many articles on software. Ladies and gentlemen, please welcome none other than Mr. John Hager, System Software Engineer and Tester Consultant, Grand Software Testing, USA.
Gee, I might even hire myself, I don't know. I want to talk about some challenges in IoT, and some of these we've been hearing about already in some of the sessions and some of the panel discussions, so I'll move a little quick through some of those. But I also want to, besides just identifying the challenges, maybe outline some of the beginnings of what I see as potential solutions or things that you can do with some of those challenges, with a particular eye towards looking at opportunities for you as maybe managers or testers or support people. I'm been in the last few years kind of devoting myself to helping people first learn about testing through things like ISTQB, but then also to build the skills, because to me knowledge is only a beginning, certification's another step in the beginning, but skills and knowing a lot of options. As mentioned, I've been involved with computers now for not quite, but coming up on 40 years, and it's changed a lot in that time. And IoT is kind of the latest craze. We've heard about that. I spent most of my career with embedded systems. I was actually one of those rocket scientists you hear about, space shuttle and things like that, way back when. And interestingly, embedded combined with mobile, and you kind of get what we're seeing in IoT. So we're still learning about IoT. I won't kid you there. I see a lot of opportunities for you. And start out, James Whitaker, good friend of mine, always likes to start out with a story. If you ever get a chance to see him speak, do, because he's an excellent speaker, much better than I am. So IoT device right here, kind of first generation Apple Watch, and it wasn't an Apple Watch, it was a Fitbit, was used not too long ago in the US. A gentleman was doing some exercising and went into some kind of heart issue. And I don't know exactly what the heart issue was, but it was enough where they took him to the hospital. And we use these things to track our fitness and calories and how long we're exercising and things like that. It's kind of a personal little metric. You wouldn't think that it's a big issue, but the doctors took the thing off, loaded the software that had been recording some data, and made medical decisions based upon what the Fitbit told them the heart had been doing for the last hour. That puts this device from just kind of a nice little toy into making medical decisions. Making medical decisions, to me, is a very critical kind of thing. I'd like it done right, particularly if it was my heart. So when we talk about IoT, I think we have to think a lot of these devices will just seem simple little things, maybe a light switch in our house, as an example. But what we're starting to see more and more is these devices have a lot of other things that they can be used for, such as medical decisions, or sometimes maybe security and privacy issues. So we as QA people, we as developers, we as testers, I believe have to start thinking of these devices as more than just nice little watch on my wrist. That comes with some prices. You have to have, besides the watch, right, it's connected to this thing, smartphone. What's this thing connected to? Well, this thing is connected to the internet ultimately. There's lots of hardware here. There's lots of software here. We have to think about all those things when we're doing that. And as I said, we're seeing more and more where these devices can either harm people, kill people. You see varying estimates. The numbers, I don't necessarily believe any of them, ranges from tens of billions. I've seen numbers hundreds of billions. Some of the other speakers show those kind of charts. Whatever it is, it's probably going to be a lot of things. How it unfolds, we don't exactly know. Will it be industrial and government first, and then limited personal use, and some combination of those things? Probably. But there'll be a lot of opportunities for companies to first start IoT, and for you as testers, as QA people, as developers, to, I'll say, further your careers. And as I kind of said, my career's been a long time. I started out, by the way, using punch cards. That was my first programming. So you're always having to learn something new in this business, kind of get used to that. So I've outlined some challenges. These are mine. The ones there in red are the ones I'm going to talk about pretty quickly here. There's a lot more depth and detail. I'll do another session in a couple hours that will explore one of these in a deeper dive, and then I'm doing an IoT session tutorial tomorrow that'll be yet deeper. And so the ones in black I'm not going to talk a whole lot about. They're important. I just have to limit myself. So one of the things I see first with IoT that I'm not sure normal software people fully appreciate is the nature of the hardware element of these things. There's unique hardware in here. There's sensors. Depending upon the phone you've got, there's 20 to 30 or 40 sensors and connections going on there. A lot of hardware, literally tens of millions of lines of code in these things, a lot of things to test. It's very complex, much more complex than when I started into development and testing. So the other next one down there, the number of devices. I mentioned billions. All those devices, the software in them, are going to have to be QA'd, evaluated, developed, and tested. That's going to present a challenge. Many places in the world are struggling right now finding enough good developers, good testers, good QA people. There's shortages in there. So a lot of us are looking to third parties, companies and countries like Malaysia to help on those things. The third item down there, they're talking about huge amounts of data. I'll get into that. But the amount of data that's being talked about is a little bewildering. That leads us quickly into privacy and security issues. I already kind of mentioned about the heart issue. Do I really want my heart information being sent out to the internet? That's a question that we'll kind of look at briefly. And that's the connectivity, the last one down there. These things are going to be connected, but to what? To who? Who has access to those things? And the companies that are producing these things, what you find out when you talk with them a little bit, one of the big things they want is that connectivity because it gives them access to the data. We put software in cars for years and years, embedded systems that I worked with, but we didn't have any way to get the data. It usually just sat inside of the car and was lost. Now we can download that, and it raises the questions on the connectivity of things. Several of the other presenters showed charts, something like this is my variation on it. IoT is software, it's hardware, it's a system, it's a tool, it's technology. And the purpose of this chart is to kind of show up there in the left-hand corner, you have the physical systems that go back hundreds of thousands, if not millions of years, stone tools. and things like that. And we went through the Industrial Revolution and the building of cities on the middle part and lower part. And somewhere now about 50, 60 years ago, right about the time I was a child, computer systems started appearing. I consider myself a second-generation programmer and tester. The people that taught me and that I learned from were first generation. It's interesting because some of those people are still alive today. Some of the pioneers of computers, like Jerry Weinberg, who gets credited by some as being the first software tester in the world, he's still alive today and writing. There's not many fields that can say the founding fathers are still alive. We're in one of them. And so you move those systems forward to the bottom right-hand corner there. What we're now getting in IoT is what we call the cyber-physical systems. These are computers, software that interact with the real physical world. They do something. They're starting to drive our cars. They're starting to measure our heart rate. They are going to be controlling our lights and our heating and our air conditioning and on and on and on. It's going to be bewildering how many things we can do. So the kind of space that I like to think of is we started out in the old days kind of on the right side there. It's what some people call big iron. It's now kind of morphed into the cloud and server farms and things like that. But those kind of computers are still around in isolated facilities somewhere. And somewhere in the late 1970s, when I was doing my programming and first getting paid for it, the first personal computers arrived. I actually bought, when I was in school, a personal computer. I was the envy of all my friends because it could network, I could get online. It was a 300 baud acoustic modem. For those of you that don't know what that means, it was very slow and it worked by sound. But I was still the envy, kind of state of the art. It progressed. I don't think of those days any of us ever would have imagined you'd all be walking around with supercomputers in your pockets. But that's kind of where we got to in the mobile smart there at the top. At the same time, the world I came out of, we were doing embedded systems. And the worlds were kind of separate. To the point where when the first viruses appeared on embedded systems, the people that found them were over in the IT world. They found these viruses. They had no idea what the viruses were talking. And the name of the virus, by the way, was Stuxnet. They didn't know what a PLC was. The two worlds had been divorced for so long that they had to go buy one of these things to see what a PLC and a SCADA was. And we started seeing this merging of the embedded world with the mobile smart world, good 5-10 years ago, because I was talking about security issues way back. People said, doesn't happen embedded. We don't think there's anything to worry about. I don't get that anymore. And we've come together there in the IoT. And it's going to grow and get bigger. On that. So you go from millions of devices to billions of devices in that thing. A little definition here, I won't spend a lot of time, but IoT devices, cars, cell phones with links to the watch. The one down there in the right-hand corner, a little hard to see. A gentleman that's helping me with my next book has one of these things. That's an insulin pump that he wears on him all the time. It monitors his blood insulin levels and gives him insulin when he needs it. It is able to be connected to his smartphone and to his doctor. If he gets in trouble, he'll get alerts. His doctor will get alerts. It's interesting. It's beneficial, but it's a little scary. And we have the devices in our cars. I mentioned, I include the picture in the lower left over there. That's a car. It's actually a car in Colorado from where I'm from. If you look very, very closely at the picture, the car is covered in drapes. It is a test car. It is under testing. The reason the manufacturer is covered in drapes is exactly what the car looks like has not been released to the public. But what they are doing is field testing. And ask yourself this, come to some of my other sessions, why are they testing a car in the field in Colorado? So My division on segments looks kind of like this. You have the industrial side and the government side over here on the left. You had the consumer products, which is what a lot of people think, watches and home security and smart homes, those kinds of things. And then there's kind of a middle where there'll be companies that are using the data coming from your smart home to figure out what you're doing and maybe sell you other devices. There'll be office, there'll be medical. It's kind of in the middle. It's both industrial and personal at the same time. And these are only partial lists of the kinds of things we'll see on that. So my first challenge, the software and the hardware. A lot of you are familiar with software. A lot of you are probably testing software. That's good. But when you move to IoT, you're going to have to start thinking hardware a little bit. And this is the embedded world that I came out of. I viewed testing as both hardware and software, could not divorce the two. It got you into some varying levels of testing, starting from pure software, going to integration, going to hardware, software testing, to system testing. But you got to think differently with that. So things like requirements, you know that one, that's tried and true. Risk-based testing that some of the ISO standards talk about, that's certainly true. But the ones I want to talk about that you maybe have only heard about in this session, model-based testing, math-based testing, skill and experience-based testing, I mentioned that a little bit already, and then some things on standards. Ina talked yesterday morning. And then was in a panel session, some other things. Organizations she's out of is supporting a group called OMG. You see that here in a few slides. Big on model-based engineering, model-based testing. I believe one of the differences that we will see in IoT is we will have to be having models at many levels, development, QA, test, security. It will be a different world for those of you that have never really experienced using kind of formal models. Now, it gets argued that all testing involves models. I won't disagree with that, but a lot of us don't really think about modeling when we're doing our testing. I think we're going to have to start. The thing in the middle there, UML, Unified Modeling Language. It's an industry standard out of OMG, and there's a group underneath that doing something called UML testing profile. UTP 2.0 is literally being last set of edits done right now because I'm one of the editors on that too. So model-based testing has been big in a few domains. Maybe not everywhere that you've worked, but telecom, some financial institutions, automotive, aerospace, few sectors in the USA and Europe have been big on it. I would encourage Malaysia to get involved. We reserved it for what I would call high integrity systems. In other words, things that either could cost you a lot of money or kill somebody. But as I just mentioned, IoT looks like more and more it can have effects on us and our health and financial well-being, even when you don't think about the watch causing that problem. So model-based testing, I won't go into in detail, but we can support test generation, test plan generation, risk analysis. We can support integration with it. We can support automatic code generation. And so it moves a lot of the engineering activities further to the left, which you hear about a lot of places. People want to move things to the left. Modeling can help with that. As I said, we're at 1.2 on the UTP. 2.0 has been voted on once. We'll vote on it one more time. It'll be out next few months, I suspect. You have to have tools with this. You have to probably automate. Several of the speakers mentioned automation and testing will be critical for IoT. I do support that also. It aids in understanding, it aids in communication, the models do. The list there at the bottom, I won't go into those in detail. In modeling, once you get into it, and I've been doing modeling both on development side and testing side, probably not for 40 years, but in the order of 30 to 25 years certainly. There are issues with it. It's not a panacea. You can't just do model-based testing. You have to use other test concepts and approaches, which I'll outline here in a moment. There was a challenge too and a pattern too with one concept. When I went to school, there wasn't computer science. There wasn't software engineering. You had math, you had business department. Math, you got trained in Fortran. Business department, you got trained in COBOL. That was about it. I was a mathematician, also a civil engineer. There weren't many of us that knew math and engineering and computers, and they kind of shoved me right away into embedded systems. And the rest, as they say, is history. So I have a fondness for mathematical techniques. And that's what we're going to talk about here. It allows us to deal with a lot of these problems like big data and combinations of things. An example here, and I'm not going to spend a lot of time in this session on it. In like another hour or two, I'm doing some of these same charts and a much deeper dive on this. But one of the problem questions I get, both from the mobile community and soon I suspect in the IoT community, is we have the Android fragmentation problem. This is an Apple, by the way. Apple has it a little bit, but Android fragmentation, there's many kinds of OSs, there are many kinds of hardware. If I'm developing an app, which ones do I test? If there's hundreds of them, how many tests do I do? So a little thought exercise here. If I think Android hooked to the Internet of Things there on the lower side, hooked to some different routers, I'm going to be figuring out later today how to work with some Wi-Fi routers here in the room so my stuff tomorrow works. Different communication channels, different home communication protocols, and then all the different data that can go in there. If I add all those things up and multiply them in the combinations down there at the bottom, I get that I need to do, as an example, 65,000 tests. Anybody want to do 65,000 tests? Probably not. Be job security, right? Because you'd be testing probably for the rest of your life, running 65,000 tests. So most testing learns that you have to select out of things. That's things like boundary value analysis and equivalence classes. Those are all mathematical selection techniques, actually, based in set theory. So extending the examples a little bit and come to the session, and I'll show you the tool that actually did this. I can go from 65,000 tests down to basically 120. I can do 120 tests. And it's mathematically sound when I do that. We'll show that in the session. There's other mathematical techniques. I list them here. I'm not going to go into the detail. The one we were just talking about is combinatorial testing. But there's things like design of experiments, which is a little more on the hardware side of things. There's random testing, which is popular in security. Several of us mentioned fuzz testing. That'll come up later. There's some statistical sampling. Now, the one class I really hated as a mathematician, by the way, was statistics. But then I ended up having to do it anyways. But there is statistical testing. And then in the bottom are the ones you're actually familiar with, because these are the classic test software techniques that we talk about in the domain of things like boundary value analysis and equivalence classes, and the ones that ISTQB talks about. Those are still mathematical techniques in my experience. Next challenge, next pattern that I think we want to work on, and I've been working here in Malaysia. This is my 4th year here, by the way. Love coming here. Slowly getting to tour around the whole country, little bits at a time. Like the food, my only complaint is I eat too much here. So I had to go back next week to Colorado and go back on a diet. Thank you very much, Mr. But the food is great. But I'm a big believer that from knowledge, you have to move to getting skills and experience. As I said, I've been doing this for 35, 40 years. I'm still learning. I'm still learning on this stuff. Get used to that idea. It's a journey that never stops. I mentioned we can do some of these things like model-based testing and some math stuff. Those are good things to have and do in IoT. But I'm also going to advocate that we need exploratory testing. And this is where your human brain excels. We have yet to figure out how to model it or build it. I'm supporting a couple efforts that think maybe they can do something with what's called deep learning. I'm supporting because I'm their hired skeptic. You have to have a skeptic on the team. But exploratory testing is basically using your knowledge, your brain, your experience to design tests and run them on the fly. And if you see something funny, you kind of go follow that. There's a pattern we show with that that we teach in some of the classes I do. The basics are outlined here. I believe that exploratory testers and testers in general develop patterns in their head. Human beings are programmed to see patterns. Anybody ever looked up in the clouds and seen a bunny rabbit in the clouds? There's no bunny rabbit in the clouds, by the way. But we have that programmed into us because once upon a time, particularly here in Malaysia, I think, you were in the jungle, and the thing that was in the jungle was a tiger. And it was really advantageous to spot that tiger in that pattern and run the other way. And by the way, you don't have to outrun the tiger, you just have to outrun the slowest person in the group. Some of you get it. My wife gets that. She doesn't like that one. But we're programmed to see patterns. Testers, as they develop skills, develop patterns. The book I wrote that was referenced was about patterns that some of us think we've identified that can help you jumpstart getting the patterns in your brain so you can do better exploratory testing. And we wrote it on software when I did it, with a little bit of hardware. And I've had people come up and go, well, it works fine for software, but not hardware. So this one I'm showing, we can do it with hardware too. There's nothing magical about software. In fact, in IoT, we're going to have to be able to handle the hardware as part of our testing and part of our QA. Now, hardware activities are a little bit different, and that's going to take you into a standard here that we'll see in a little bit called IEEE 1012 for verification and validation. So it's going to move you up some levels. But the message here is exploratory testing isn't just for software. It is the kind of thing that I want everybody to learn how to do better and build patterns to work on, including as you move into the hardware and system level of things. So some of the advantages on this slide here for exploratory testing show up. Doing okay on time. You can get rapid feedback. I've gone into projects, firefighting projects, or projects where they said, gee, we're in trouble, let's bring in some experts. I was one of those experts they tended to bring in. And within inside of a week, we were able to define the problem, define tests, and go run them. They weren't cheap, but we were able to do that. So it was very rapid. It was rapid learning, rapid feedback. It was based, when we did it, I realized, and this was many years ago, that the team of experts that was doing it had these patterns up in their heads already. That's when I first started thinking about the notion of attacks. You can get coverage of data and improve reliability. It's certainly very useful in security. There's a whole field of security testing now where I believe most of the people that do it, and I don't consider myself a security testing expert, by the way, even though I talk about it, but the people that are doing it have these patterns that they've been developing up in their head. They're very, very good at it. It's very lucrative for them. Some of them make a lot of money. I don't know who he was, but one of them made $1 million US in the last year. I would like to be that person, because I wouldn't be here, by the way, if I'd made the $1 million. So it wasn't me, but we can find faults. We can use it in testing this big system of systems where things are in the cloud. Will you find all errors with it? No. Will you find some interesting errors that are hard to find with these other techniques I was just outlining? I believe the answer is yes, because that's what these security guys are doing. So I'm not going to read this whole list. It's kind of for reference. Some of these things are out of the book that I wrote that shows how IoT could benefit from some of these attacks. I'll tell you now, and you can run out on your smartphones and your computers. I have a second book. The first part came out about a month ago. Part 2, you're the first people to hear about. Part 2 was published about 3 hours ago this morning. It's an online ebook. Both parts right at the moment are free. Is that a good price? People like free? I've been in Malaysia, everybody, we like your book, it's so expensive. And I was like, yeah, you're right, it is expensive. My publisher said that. This one is me, it's an online book, it's an ebook, it's an Agile book. They are not complete. When I say Agile, the book 1 is 80%, book 2 is 50%. If you go out on LeanPubs, and it's leanpubs.com, I think. If you go out on that and search under IoT, it's got a search feature. Somewhere in that list that pops up, you'll see part 1 and part 2. There's 3 more parts. They'll be out probably one every other month or so. I am looking for feedback. That's the lean, Agile part of things. Agile, we try and get it out to customers. And feedback, I won't swear that the English is very good on these things yet. My wife, who is my editor, has been very busy, and so I haven't been persuading her to do many edits on these yet. So, price is right on that book. And please give me feedback. That's you're now my customers and also my best critics. Standards. Some of you are aware of standards. There's a Standards Malaysia group that supports things. In ISO, that's where I met a lot of the people here in the room. I'm the ISO IEEE editor for the testing standards. I'm the IEEE editor for other things, and I'm the OMG editor. By the way, they don't pay me anything for these things. It's all volunteer. I give them myself freely. So I mentioned IEEE 1012. 2012 version is out. By the way, my computer's just told me, oh, I'm supposed to check my blood pressure right now. This is like my second wife here, always reminding me what I should do. Things are flashing down here and popping up on my, I have now 2 wives, 1 legal, 1 kind of virtual. I can turn this one off, by the way. Okay, some of you appreciate, the men are appreciating that, the women are like, wait a minute. IEEE 1012, we've been going through a series of revisions. The 2012 version was our first attempt in IEEE to move it from an IEEE format to an ISO format. The reason I mention that is IEEE is going to support, with ISO 1012 becoming a worldwide standard and not just an IEEE standard, which makes the audience much broader. It's been ongoing for, I guess, 2-3 years now. I was the man in the middle. I wasn't doing a lot of the hard work, but I was on both committees, and so I've been trying to negotiate and bring everybody together on it. V&V will be one of the big things for IoT. And the reason I say that is it's above standards that you'll see here in a moment, like 29119. It relates heavily to systems and software and hardware. The version prior to 2012 was strictly software. Those of us in the working group said, gee, this whole new world is coming. We need V&V to address the whole picture, systems, software, hardware. So we expanded it. And in the next few years, maybe 2 years, if ISO does what's called a fast track, it'll become something that's available. It's available now, but it's be world standard. 29119. Many of you have heard of that. The Malaysian's been heavily involved in the production of this thing with ISO. Comes in 5 parts. The 5 parts show up here. There's part 1 that's kind of concepts and introduction and vocabulary. Part 2 is processes. That's kind of the heart of the thing. Lots and lots of processes on that. Part 3 is documentation. Part 4 are software test techniques. And part 5, which is just finishing up approval, I don't think it's been released to the public. It's a slow process getting everything out through ISO. But it has been approved. I think the final version may be out at our November meeting. I can't tell you what ISO does because Geneva is like a black box to many of us. But it's going to have 5 parts here pretty soon. All 5 parts have been approved. 3 of them, I guess 3 years back, something like that, maybe 4. Part 4 came out about a year ago, Part 5 literally right now. It's fairly comprehensive, but I won't talk to it in detail, but it is a standard that needs some thinking, some customization, tailoring. You cannot, in my opinion, use everything that it says to do on a project without incurring a lot of costs. So if I were doing a nuclear power plant, I'd probably want to use the full-up standard. Why? Because if a nuclear power plant goes wrong, it affects an awful lot of people. I just heard that the Fukushima plant, which was an earthquake, nothing to do with this kind of issue, cost every Japanese person about $350 US to clean that thing up, and they're not done. So that can be a lot of cost. So that might justify a full 29119, all the parts, all the procedures, all the processes, all the documents. But most of us aren't going to be nuclear power plants. You will want to modify and figure out what documents are right for you, what techniques are right for you, and negotiate like on some of the processes. OMG, mentioned that. Very big in Europe, a few places in the US, but very big in Europe. The UML testing profile 2 should be out in the next few months. It basically defines a language. It does not define a process, but it defines language and constructs. Those of you that saw Ina talk on some things, she talked about TTN3, which is an English modeling language, but it's still my view. I think hers a modeling language. When I say English, it's a human language. But UTP has a more visual aspect to it. Not totally, it has both, but humans deal well with pictures, and modeling with pictures and modeling tests with pictures, like the one that's showing up there, has some real advantages to it. Data, on data things. When they talk about IoT, the numbers of devices are mind-boggling. The amount of data is going to be even larger. We don't quite know yet, something didn't come across there, the types of data that are going to show up. And when I say the types, I mean the constructs. I also mean the amounts. We're going to have petabytes and exabytes, and then I've found things like zettabytes and yottabytes, and I don't know how many of those things are. They're huge amounts of data, just astronomical. No human being, when I first ran into terabytes, I thought that was a lot of data. I didn't know how to deal with that much data on things. When we're talking things that are 100 or 1,000,000 times bigger than terabytes, no human being is going to be able to process that. That's the kind of data that IoT systems, smart cities, those things are going to be generating. There's already a lot of talk about using deep learning, artificial intelligence, scanning systems. I'm calling some of the things I'm talking about what we will need are kind of self-organizing data. You will go in, you'll define some needs, maybe to an AI system, which is working with a statistical analysis system. It'll go off and think about it, and you'll start seeing small snippets of a zettabyte worth of data coming to you, maybe in a nice graphical form to organize. And the reason the birds are there, the birds organize into a pattern. Nobody tells the birds how to organize in a pattern, but if you look at it, there's a pattern there. When we're talking those kind of levels of data in IoT, that's what we're going to have to do. I'm aware of several organizations and efforts trying to organize that data. And when I've done this presentation other places and some of the tutorials, people go, well, you didn't tell us enough on the data. Well, there's a reason for that. We're still trying to figure out how to do this stuff. I can identify it as a challenge. I can say some of the things that we see happening. As far as I'm concerned, nobody's actually pulled it off to the degree that I think in the next few years we'll see with things like, anybody heard of Watson? It's an IBM product. It beat humans at Jeopardy and chess and things like that. IBM is using Watson in this field. And past that, I don't know what that means yet. The one that scares me, maybe should have been a top priority, several people mentioned, is security and privacy, and I view them as separate. Security is somebody bad gets into your system or your data or controls your IoT device. In the US, we've seen people hacking the nanny cams, as they call them, and getting in and starting to take pictures of small children and knowing when you're home or not home. That's a security issue. We've seen people hacking cars quite a bit while the cars are driving and crashing them. So far, it's all been what we call white hat hackers. We don't know of any black hat bad guy situations, but I'm sure there have been. There's people in the US stealing cars now using these kind of systems. So I guess those are kind of bad guys on that. On the privacy issue, do I want my heart data broadcast to everybody in the room? I got some people going, no. Other people going, you know, I'm not caring about your heartbeat. It depends. It depends upon how the data is used, right? So I mentioned some of these, and by the way, one of the speakers said, not aware of anybody hacking a medical device. I am aware of some medical devices that have been hacked purely by researchers. There's a lot of researchers that are doing this stuff largely to show it can be done, which is good. Because once we know it can be done, we know the bad guys can be doing it, we can test for that and QA improvement and have a device that's hopefully more safe. A Coventry security scan of an Android device, because it's open source software, showed about 350 defects that were kind of bad, 88 of which were high risk. Last time I checked, which was probably a year ago, only half of those had been fixed. In the US, we had the Apple phone that was cracked into. The FBI, that was the thing I was referring to. The FBI paid somebody $1 million for the back door. Nobody knows what the back door is. Apple, if they know, aren't talking. The FBI definitely isn't talking. But somebody made a lot of money out of that security hole. In my book, I outline 6-7 attacks. These are just very simple beginning attacks. I have another book called Hacking Exposed. I kid you not, it's about that thick in terms of number of pages, with lots of methods and techniques. And if you go online, you find more. If you go online to something called the dark net, which I don't recommend anybody do, by the way, but if you do, there's a whole subculture on the internet that does this stuff. It's kind of terrifying, actually. And it's terrifying from this perspective. Privacy. How much of my data do I want to give? Do I want somebody to compensate me for the data they're collecting on me from my watch? The companies are wanting IoT devices largely because they can access what you're doing, how you're using it. How many people are on Facebook? Exercise time, show of hands. You're all aware that Facebook knows everything that you do and records everything that you type and do, yes? And they do that because you are now testers for Facebook. Did you know that? And this is part of what's called DevOps. We're going to see this a lot in IoT, which means we are moving our users to be testers, and we're monitoring everything they do, which is a legitimate kind of sub-technique, by the way, but it raises some serious privacy concerns. Enough where me, the paranoid person that I am not on Facebook. And we see down here some of the things, secrets and medical issues. And yes, I am from Colorado. Yes, marijuana is legal in our state. I can do a drug test, mister, if you feel that's necessary. But it gets into some strange things in Colorado where it's legal, but it's not legal. Don't know what that means. Finally, connectivity. This is the one that brings a lot of those things I was just talking together, and they put them out on the networks. Things like the SOTA, the AI stuff in the cloud, where a lot of us are going to start as, I'll call it test analysts or QA analysts, maybe not even testers, because I'm not running tests anymore, am I? I'm kind of taking that mega data, pulling it out, looking for that kind of thing like Facebook does that says, oh, there's a problem, we should figure that out, we should fix it, and 24 hours later we put a patch out. How many people get these updates to this thing like constantly, right? You know, at least once a month I get one of these. And then I start getting threatening notes. Your phone's out of date. You're at risk and things like that. So we as V&V people, test people, QA people, I'm not sure what to call us anymore, we're going to be functioning in this world of connectivity and protocols. And if I have access to data, do I need to do what's known as sanitize the data so that I can't tell who the person is? There's systems now that can do that. All I see is a composite set of information, so I can't tell that it's a mirror doing something wrong. Or Herman. Where's Herman? Herman says he wasn't gonna. I apologize to Herman, and he was the only person in a Japanese conference that I knew, so he got picked on. But no question, I just pick on you a little bit. So we see these things test early, the test often. I think in IoT we're going to be having constant, ongoing, you can call it something other than testing, but to me it's kind of like testing with the user as tester, with people as analysts or data V&V, QA people, looking for something that isn't right or that can be approved. We'll have to think about risks. We'll have to think about changing requirements. This will have to be automated. You can't process a zettabyte of data, manually. Well, I guess you could, if you're kind of very persevering. These test environments in IoT will have to be for connectivity factors. We talk about in the security worlds and several of these things what are known as sandboxes or test environments, and what we mean there is to do some of the things, particularly in security testing. I can't do it out in the real world because I'd be letting viruses go. That's a bad thing, not to mention illegal in many countries. So I have to create a special environment to play in. I have to figure out how to have hundreds or thousands of devices. There's now companies, at least in this world, that make those things available on the network that I can access. This kind of stuff is going to be coming along with those kind of things. So, just about right on time. Got started late. As I said, I come from Colorado in the mountains, and there we have mountain time. I've noticed Malaysians have Malaysian time. I'm very comfortable with that. We're very much used to it in the mountains. The big cities down in Denver, Colorado, they don't know about that. They get confused when they come up in the mountains, and we say, I'll see you at 9 o'clock, which means somewhere between 9 and 10 or 11. So these patterns appear in the world. Remember I said we all work with patterns. These are reoccurring patterns. So for me, IoT has a lot of opportunities. I encourage you and your companies, a lot of companies are going to be moving into IoT anyways, and be ready. When your company does that, presents you with a good opportunity if you're working with one of these companies. If you're a little more venturesome, and I was never this way, you can found startups. By the way, book 2 that just came out talks how to set up startups and things like that. I've talked with people in Silicon Valley that do that. I just live in Colorado. I don't do startups, but I have references on that. The amount of data and information that we have on IoT is limited. So these things that I'm talking to you, the challenges and techniques that I'll put in the book, they're liable to change, okay? And some of them may change because of things you learn and tell people like me. There's a lot of challenges. I mentioned a few, not all of them. There's other ones that are going to appear. There's some patterns that I can think can help. And we're going to put IoT in everything. Grandma Mastura over here. very happy grandmother, Mr. New baby last year, was talking with her daughters. Can anybody think how a diaper could be used with IoT? I got some laughs. Come to my other sessions. I'll talk more about that. But we actually came up with a concept on that that makes lots and lots of sense for those of you that have had to change diapers. So at any rate, I mentioned my book, since I put these charts together, as I said, part 1 is kind of out at an 80%, part 2, 50% just this morning. My book's been out for a few years. James Whitaker has a bunch of books in the same kind of vein. I like to mention where I come up with all this stuff. A lot of these things I just reuse from lots of smart people that write books and good friends that I like to give credit to. Here's some resources on things. People think I'm smart. No, I have lots of books and I know how to Google. Little technique. If you get asked a question at work that you don't know the answer to, say, I'm really busy right now. Go back to your computer, type in Google, figure out a few things. You got to sort on what Google tells you, by the way. Write that up and send that back. People will think you're brilliant. And that's how I got here. And more references on stuff. I think we're done, more or less on time. And come to my other sessions. And I think we have a break, yes?